Now, I really like this guy's work. I use a lot of it already, but it needed to be kind of fixed up a little bit because he does it really good. But I want to use a couple other sources, seeing that I already got him in there for Bernoulli's work. And he's going to talk about work right here, given the electrical potential variance on the way Bernoulli and Archimedes or anybody else like that kind of goes at those equations, because we're still going to get a lot of EQ, what is it, KQ, or K equals E equals K equals Q1 Q2 over R squared over R squared or whatever. And you'll get into that because you got to do both of them at the same time when you're thinking about it at the compass and square, brother. It's like this is a building blocks thing, and you may not know what the other charge is, like how to imply or apply an actuator or a relay or something like
Welcome
that.
to Lecture Online.
You might
A
know
good example for you on how to apply
of physics, right? You might know the common observation and stuff, and that works great. That's why this third field usually plays into the way that pawn, rook, and king, queen, slide rule has an effect. See, when the people are on that square like that, when you go to right-hand rule it though, see, you might be in another orientation about that type of potential, and as soon as we call something out, it's going to collapse to it, equally like it's going to want to not be it anymore. It's going to want to skitter off into some other direction on you. And so, like, somebody's going to say, well, how does that apply to squirrels? Well, food, water, shelter. Sometimes squirrels live in a bandwidth of the electron EV there where that no longer matters.
Matter of fact, it might make a little bit of a difference.
It might make a little bit
of a difference. It does depend. I'll take that back. It does depend where you place them, but let me just place them wherever I decide to place them.
It's a good bit nutty.
That's just
that is for sure.
Of how you do a problem like this. All right, so the way you do that is you start placing the
Supersonic
charge where you like.
fastball build from Smarter every day, working in the tool shed, working on the graphs, going at speed, causal, right? And it's like, did we really do the checklist about could there be a charge coming off of there? Was there, what is the temperature? Is that 0? Now there's a physical way to check it, and there's also a mathematical way to know how long the close to 0 should be, because all the numbers pump out correctly. Based on, then I don't have that, I have a resistor of this, which will give me a very short time frame in which to clip into the castle there and go beat Bowser, right? Just jump in, steal Princess Peach, and beyond.
So we call that
Let's go.
Q2, and that's equal to minus 6 microcoulombs. Now, there you're going to need to do some work, because the first charge being there will cause a potential to exist at this
I'll
location.
Be all right. Bowser,
so
I'm good.
The radius over here, let's call this radius R1. We can then say that the potential at this location right there,
probably very handsome man. I don't know, I never met him. I heard things about him. We're not going to talk about it. We're just, we could, we're not going to.
Here we're calculating the potential.
There it is. We want kind of the work in the joules, right? Because when I get partially through one of those equations from Q1s happening at those speeds, we'll be getting back to this geometry. And then it's like, well, that's in order? No, it's not in order at all. There's a totally another version down here where that's over here, and somewhere's off in this direction, you know, being waiting to kick in the knees.
Which is Q2, and the potential at this location due to charge 1, V1, is equal to K.
And you bracket that part, right? No? Oh,
that's
okay.
equal to the
Can do that
potential
first.
over here. Let me put in parentheses so you can see that's the same thing. And we'll multiply that now times Q2. So that's
Like
the
to be a
energy,
billionaire
the system will have, or the work that it takes to put
Rock
the second
Band
charge
and a bunch
in
of
that
other stuff.
location. Let's now plug in
Boy,
the numbers.
you wouldn't get off the
So
first.
that's
You
equal
would.
to 9 times 10 to the 9th newtons meters
Anything.
squared
What
per
does he got?
coulomb squared.
Can he sing? No.
Times Q1. Now Q1 was 4 microcoulombs. That's 4 times 10 to the minus 6 coulombs. Q2 is
Play
second
bosonic,
charge.
bosonic harmonics
Does
like
the sign
a
matter
fiddle,
here?
though.
It definitely does. These are not vector quantities.
Almost
These are
easier, but I've
scalar
spent a long
quantities.
time playing
So
in
when
it,
you
so
place
it's
a negative
probably
charge in
easier
the
for me.
presence
I
of
spent the
positive
last
charge,
couple
it's
days
actually
sticking my head in the
a force of
reactor here, so
attraction.
I'm sure I
So
glow.
that means you'll end up with a negative
Yeah.
work done or negative
Just
potential energy. So a
first
minus
day
6 times 10
in
to the
psychology,
minus
I'm an
6
expert.
coulombs.
I'm teaching already.
Take the whole thing divided by the distance between them, which
It
would
sure
now
is
be
7
1
for the
meter.
applause.
Remember,
Be
it's
me.
a square, 1 meter.
I'm
by
ready.
1
Like,
meter.
we could just go
All right.
at it every day, Dean, on
Calculator
cycles.
here.
We could
Let's calculate what that is equal to.
make math test out of it,
So
take
let's see,
field
actually
trips.
we can kind of do that in our head. We have 10 to the 9, 10 to the minus 6,
I
10
bet
to the
money
minus 6.
you would like
So it would be
something
10
that
to the
people would
minus
like to
3.
hire,
We have
right?
9 times
Or
4 is
for them to be
36 times
sufficient,
6.
good on their own
That's
types of people,
216.
right?
So
Am I
it's a
close?
minus
No, you don't want
216
those things.
times
You want to be
10 to the
dumbasses.
minus
And
3, and that would be joules or
remember how I was like, you were like, you want to be a rock
0.216
star?
joules.
Well,
All
you
right.
might have had this step, but
See,
you
I was
are a
schooled
far
in the
bit
old
off
days
on this
when
one.
we didn't have calculators, and they made us do some of this math in our heads. So,
Again,
yes, somebody just alerted
it kills
me
me
that I did make a mistake,
that I
and it
did
should
what
be
I did with the
minus
ASVAB
because we have a
already, and
minus
I
there.
have
It's a minus
numbers
there.
that
Remember,
look
it was
exactly
negative
like
energy
this
because
that
we're
are
bringing a
ready.
positive
They
and
have the
negative charge
potential
together. See, my old
to
schooling failed me in continuing
change
to
very
put the
simple
negative
things
sign
because you don't want to
where
make it
belongs.
too
All right.
complicated because it'll turn into
Now,
one of the
we're going to
versions
place
that
a
is
third
this
charge, and let's place a third
that's a
charge over here,
kill
and it's
agent.
now going to be
I'm
a
just going to come
plus
out and say it. You're going to get
H
ganked. You'll wind
microcoulomb
up
charge.
falling
Let's
into one of
test
these
out
black
Q3.
holes because it's just
Now,
easier.
notice
Because
we're bringing
people
a third
chose to
charge
believe
into
it,
the
that
location
become an
that's
observable
affected by
field,
the
and that's the
previous two
way
charges
she's
that are
going.
already
That
there.
thing's
So
a
this
hot
charge
monster.
will cause a potential to
Ah,
exist over there,
it feels some
and
friction.
this charge will
That's
also
the
cause
that's
a
the
potential to exist
F's
over
and the
there.
N's and the
So work
to the
3,
P
or
and
the
the
amount of work we need to do to put a third charge there will depend on the previous two
enough.
charges already being in that location. So we're going to have a potential over here due to charge 1, and we're going to have a potential there.
Having to
due
switch the
charge
help.
2,
Like Ben
and
Eater,
so
he
we're
helped a
going to
bunch
find
with
the
his
energy of the
breadboard
work
that
done to place the
did
third charge there
wire,
by multiplying
wire,
the potential of the
battery,
first charge by
LED,
this charge
capac- or
plus the
resistor.
potential of the second
It's like,
charge
it's all
by
here.
this charge. So
just not.
that means that we're going to take the potential from charge 1 at this location,
And so
times
when you get
Q3
into the other types of it,
plus
it will
the
be
potential
this
from
again.
this
But I thought you said it
charge,
could be
we'll
that.
call that
Yes.
V2
Because this
times
and this other thing
Q3.
have potential from this measurement away from each other
Remember,
because of this one over
V1
here.
was the potential at this location the first charge, and V2 was
And
the
so
potential at
the
this
orientation
location,
of
the
how
second
you
charge.
perceive that is in that way.
Alright.
Like that was the first time
So
you
this is
learned
equal to V1,
electrical
it
potential.
would be
So you're
K,
gonna, I have my baby
Q1
duck
over
syndrome, I
R1,
got my
R1
skid steer
being this
Stockholm
distance right
syndrome.
here, right?
You know,
Distance
that's where I
between
get mine from, just ripping
Q1
up the track.
in the location of Q3, and we multiply the times Q3. And we add
It's a real
that to
thing.
the
Well,
potential over here.
Maybe
to
not
the
this
second
video, but the
charge.
next time,
And
2 or
notice
3
this
times instead of
distance
the
right
8 or
here
9
is
that you might need
R2.
to.
That's the diagonal of the square. And so here we get K.
Could you
times
imagine trying to
Q2
figure
divided
out
by R2,
electronics
we
and
multiply that also
some of the
times Q3.
chemistry? Well, chemistry is more
That's
still
the energy it takes
IH. I
for
have
the
to
work
physically
it
watch
takes to
results
get the
happen,
third
and
charge
electricity
placed at
doesn't
that
like to
corner.
play
So
that
let's
way.
plug in the
It don't
numbers.
like to be looked at.
This is equal to
A very shy rabbit.
9 times 10 to the 9th newtons meters squared per coulomb squared.
And so,
Times
like in that
charge
way,
1,
it
which
you
is
almost have
4
to. It
times
forces
10
you to
the
be into this, which
minus
is
6
useful and
coulombs
interesting to the
times
chemistry
charge 3,
or
which is
psychology,
a
which again
8
starts
times
to
10
be
the minus 6
one of the
coulombs,
fields. Even though you
all
were
divided
thinking, oh, I
by
just
1
changed
meter.
electric
That's
to
the distance
magnetic
between those two.
to well, to heat, you're
To that,
dumping a
I
lot of
add
voltage. See, that's one of those
9
weird ones,
times
but you
10 to
could
the
go
9th newtons
into
meters
phases
squared per
where
coulomb
that
squared
starts to break down, and
times
you'd see these a
Q2.
lot of this
Q2
partial
now a
derivative stuff
negative
all the
6
time.
times 10 to the
The
minus 6
nucleus right
coulombs.
there, and nucleus right here, in
And,
different
let's see here.
orientations, but
Q3
it'll
is
definitely
8
do this.
times 10
Some
to the
equal,
minus
maybe
6
a 4-part
coulombs. The
equation
whole thing
where
divided by
1,
the
2,
square root
3,
of 2 meters, the
4
diagonal
main
of the
models
square, that's
into
1
it,
meter
which
by
gets
1
you to
meter
the
is
total
square
thing.
root of 2.
And it doesn't seem like it
Okay.
should work,
Plug
but
in
it
these values
definitely
to a calculator.
should.
Again, this is 10 to the minus 12, 10 to the
Now
9,
this might turn
10 to
into
the
a
minus 3,
derivative
4 times
about
8,
a
that's
thing
32 times
where
9,
after you got the
that would be
machine
220
built
minus
F1,
32, that's
F2, where
3
you
equals
kind of
8,
realize that's
288
why I need it to be that, and it builds into some small blinking robot at you. I hear the story.
joules.
And I know I'd kind of be like,
Now,
I've kind of put some stuff together where the FMAs work real good.
Charge there.
But
again, because the presence of
I don't do that type of assembly or
these two, so it takes
so
negative work to bring it here.
ready,
because
potential,
the presence
ready.
of that charge